What's happening, dogs? I'm Mr. Allen here, and we are graphing in polar right now. We got a graph R equals 3 plus 3 sine theta. So first thing I notice here is that these two numbers are the same. Thus, this would be a cardioid, okay? Now, I like to use T-charts for these. Not everybody does. There are certain patterns you can remember about how everything's going to work, but I just like a good T-chart for any of my cardioids and my limosons, okay? Now, you think about it backwards as from your, your Cartesian, your XY coordinate plane where we plug in X, we get Y. Here we're working with theta, okay? And then I evaluate to get my R, all right? So if I plugged in 0 for sine, what is sine of 0? It's 0. And then 3 plus 0 is just 3. And if I plug in pi over 2, what's sine of pi over 2? Well, that's 1. So 3 times 1 is 3, plus 3 is then 6. And if I plug in pi, I get 0 again for sine, so we get 3 again. And then if I plug in 3 pi over 2, sine's going to be negative 1 there. Unit circle is super important, never goes away. All right, so then we have negative 1 times 3 is negative 3, plus 3 is 0, all right? And then 2 pi, swing all the way back around, that's going to be 0, right? So sine of 2 pi is 0. And then plus the 3 is going to give me 3. So now we're ready to plot this thing, right? So knowing how to plot your points in polar is of a paramount importance here. If you can't plot those, you can't do this. So here we go. We got 3 zeros. So my rotation is 0. My radius is 3. And then at pi over 2, we're going to be up at 6. So 1, 2, 3, 4, 5, 6. And then at pi, we're at 3. At 0, I'm going to be at... at 3 pi over 2, I'm going to be at 0. And then over at 2 pi, we're going to be back at 3. So the way these look are kind of like, almost like hearts in a way, but not really. It's kind of like got like a little, for lack of better words, it's got a little butt to it, okay? So it comes around here, like that. Boom. All right? Now, fun fact, this is actually, have you ever heard of a cardioid mic? It's a cardioid mic pattern. So this is where the microphone would pick up. And actually, if you look at microphones, they have packaging or they have like diagrams with a polar graph on them and the type of pickup pattern that it has. That's a real deal. Okay, that's a real thing. So there we go. That is our cardioid pattern. It is sine. Now, question for you guys: what would happen if this was cosine? Curious. Let's try it. Just try it because that sounds like fun to me. Okay. So if I were to do a new chart here. And this is going to be for, I should have written it up here, but whatever. R equals, and we'll do 3 plus 3 cosine theta. What changes for that? Well, we're still going to have 0, pi over 2, pi, 3 pi over 2, and then 2 pi. But now when I do 0 here, cosine of 0 is 1, times 3 is 3, plus 3 is 6. Pi over 2 cosine is 0, so then we're going to get 3. At pi, it's negative 1. So we'll get 3 times negative 1 is negative 3, plus 3 is 0. At 3 pi over 2, cosine is 0. It's our x coordinate, remember? So then 3 plus 0 is 3. And then at 2 pi, we're back over at 6, because at 2 pi, it is equal to 1. 1 times 3 is 3, plus 3 is 6. Let's plot them. All right, that was a whole lot. 6. So at 0, it's going to be 6. 1, 2, 3, 4, 5, 6. And then at pi over 2, it's going to be 3. 1, 2, 3. At pi, it's 0, so we'll be at the origin. At 3 pi over 2, it's 3. Yeah, 3 pi over 2 is 3, right? So we're rotating 3 pi over 2. We land at 3. If it was negative, you'd have to reflect over. And then at 2 pi, it's back at 6. So now we have, let's see here. Kind of to be careful. You don't want it to be pointy over here. You want it to kind of like round, as I make it kind of pointy. You want it to like round through, okay? And there we go. We have our cardioid going to the right. So let's think about this for a sec. When I have my sine graph here, it was pointing up, right? Sine's my y coordinate, it's going up in the y direction. Cosine, it's going to the right. It's my x coordinate on my unit circle and all that stuff, so it's going to the right or to the left. Now, if we were to make this a negative or this guy negative, then it would reflect down the other way, and all the ordered pairs would work out as such. Check it out. Oh my goodness. Am I really going to do this? I am. We're going to make that negative now. What's going to happen? So if I plugged in 0 for sine, sine of 0 is 0. So this is still going to be 3, right? When I plug in pi over 2, I get sine of pi over 2 is 1. And then we have the 3 there, so we have 3 minus 3 is 0, okay? When I plug in pi, I get 0, so 3 minus 0 is still 3. If I plug in 3 pi over 2, sine of 3 pi over 2 is negative 1, times negative 3 is positive 3, so we get 3 plus 3 is 6. And then when I plug in 2 pi, I get 0 plus 3 is 3. And now when we plot these points, you kind of see how these two switch spots here. So I've got 0, comma 3, so we are still right here. And then I have at pi over 2, we're at 0. And then at pi, I'm at 3. At 3 pi over 2, I'm down at 6. And then I'm back at home base, if you will. So now, as we come around here, I have to really focus to make sure this looks nice. Woo! See how it's going down there. This is great. And you could imagine if we did that with this one here, if I threw a negative here, this would be reflected over that way. So there's still like reflections and things like that that happen just like in your Cartesian, right? Your XY coordinate plane. Polar's just a little different, new beast. It's a lot of fun. It's really cool. And yeah, we get a little very loopy with it and stuff. And a whole fun new little graph. So hopefully they didn't get too crazy there, but I feel like I always liked having some what ifs. What if I change this? What if I change that? What would happen on this graph? Sometimes it's nice to look at that and hopefully it didn't get too crazy or too messy for you guys. But thanks for watching. If you're still watching, you guys are awesome. Have a wonderful day. Like, subscribe, tell the people about it. See you later.